last one, that is estimation of percent of oxygen. Estimation of oxygen. Generally, for this also there was two methods. In the first method, the percent of oxygen is equal to the difference between 100%, total percentile, that is what, 100%, to the sum of percentages of all other elements. For example, the compound having carbon, hydrogen, nitrogen, oxygen. So this compound having only 4 elements. If you know the percent of carbon or hydrogen or nitrogen, for example, this is 25, this is 30 and this is 40. 25, 30 and 40. Then the percent of oxygen will be 40 plus 30, 70, 70 plus 25, 95. The remaining percent of oxygen is 5%. So the first method is the easiest method. It's nothing but percent of oxygen is nothing but 100 minus, total percentage is 100 minus the sum of percentage of the remaining elements. Sum of percentages of remaining elements. Simply you subtract the percentages of all other elements from 100, then the difference only will be the percent of oxygen. This method is only when you know the percentages of all other remaining elements. If you know the percentages of other elements, then only we can calculate the percentage of oxygen, simply by subtracting this value from 100. The second method, take the known weight of organic compound. Known weight of organic compound. You oxidize this with copper oxide, followed by the heating in presence of, or else no need of copper oxide. If you heat this, heat this in nitrogen atmosphere. If you heat the organic compound in nitrogen atmosphere to very high temperatures, then the carbon is coming out as carbon dioxide, hydrogen is coming out as what? Water. And if oxygen is present, if oxygen is present in the organic compound, then the oxygen is coming out as O2 gas. When you heat this organic compound in the nitrogen atmosphere, the oxygen present in the organic compound is coming out as O2 gas. Next, this O2 gas, you treat them with charcoal. Coal is nothing but carbon. When you heat this coal with oxygen, if you do the combustion, heating in presence of oxygen, heating of coal in presence of oxygen, heating of any substance in presence of oxygen, we call it as combustion. If you do the combustion of coal at the temperature of 1373 kelvins, if we heat it to the 1373 kelvins, then we get carbon monoxide. So what we will get? Carbon monoxide. Then this carbon monoxide, when we treat this carbon monoxide with iodine pentoxide. So what is that? Iodine pentoxide. So this carbon monoxide acts as what? A reducing agent. It reduces iodine pentoxide into iodine. So I2O5 becomes what? Iodine. And carbon monoxide becomes oxidizes to carbon dioxide. So by using the weight of carbon dioxide produced or the weight of iodine produced, we can calculate the percentage of oxygen. So once again, take the known weight of organic compound, you heat this compound in the presence of nitrogen atmosphere, then the oxygen is coming out as O2 gas. When this O2 gas passes through the coal at the temperature of 1373, we get carbon monoxide. It acts as a reducing agent. When we send this carbon monoxide through iodine pentoxide, it reduces the iodine pentoxide into iodine and it becomes oxidizes to carbon dioxide. By using this weight of carbon dioxide, we can calculate it. Let us see. the percent of oxygen is equal to the weight of CO2 produced by the weight of organic compound into, in CO2, what is the weight of oxygen? 2 oxygen atoms are there. So the weight of oxygen will be 16 2s are 32 divided by total molecular weight 44 into 100. Okay, that is one way. Otherwise, by using iodine, how can we calculate? Simply, the percent of oxygen is equal to the weight of iodine produced by the weight of organic compound into oxygen atomic weight 16 by iodine pentoxide. Iodine pentoxide, if you take, what is the weight of oxygen? 16 5s are 80. 80. Total weight of oxygen will be 80 by I2O5. 127 2s are 254 plus 80. 250 plus 80, 330. 334 into 100. In most of the cases, we will use this formula only. So these are the two formulas. We can use any one, but most of the cases we use the first formula only. So likewise, we can calculate the percentage of elements present in the given organic compound. Now we apply these formulas in few problems. Okay. So take this question. If 0.12 grams of an organic compound, so the weight of organic compound they given, that is 0.12 grams, containing phosphorus, produces 0.22 grams of magnesium pyrophosphate. So 0.12 grams of organic compound producing 0.22 grams of magnesium pyrophosphate. After the reaction with the magnesium mixture, then calculate the percentage of phosphorus. So we know the formula for the percent of phosphorus, that is what? Weight of magnesium pyrophosphate, Mg2P2O7, divided by the weight of organic compound into 62 by 222 into 100. That is the formula that we know. Just substitute the values. What is the weight of Mg2P2O7? 0.22. So 0.22 by 0.12 into 62 by 222 into 100. That is equal to, just remove this, here 0.22, here 0.12. So you can write 22 by 12. 22 ones are 22, almost 10s are. So 1 by 12 into 62 by 10 into 100. 0 0 cancel. So finally 6 or 12 5s are 60 and 0.1. So nearly 51% of phosphorus present in the given organic compound. This is a direct question. In estimations, they will give you the data clearly, and if you know the formula directly, we can easily calculate simply by substituting the values in the given formula. Next, move to the next question. It's based on Dumas method. So I told you nitrogen can be estimated by both Dumas method and Jhaldal's method. In Dumas method, we calculate the percentage of nitrogen by using the volume of the nitrogen gas liberated. See, during estimation of nitrogen by Dumas method, the volume of nitrogen gas liberated STP will be 22.4 ml. They given the volume of N2 gas at STP they given, and the weight of organic compound how much? 0.28 grams. Then percent of nitrogen. Just tell me what is the formula for the percent of nitrogen by Dumas method? That is volume of nitrogen at STP by the weight of organic compound into, then nitrogen molecular weight 28 by 22,400 into 100. Simply substitute. What is the volume? 22.4 ml by weight of organic compound 0.28 into 28 by 22,400 into 100. 22.4 thousands. Then 2 zeros cancel, and 0.28 hundreds. 100 by 10, that is equal to 10%. So 10% is the percentage of nitrogen in the given compound. Next, let us discuss the problem about Jaldal's method. Now let us discuss the two important models, questions asking from Jaldal's method. The first one, during estimation of nitrogen by Jaldal's method, the ammonia evolved from 0.5 grams of organic compound. So weight of organic compound is 0.5 grams. Neutralizes 10 ml of 1 molar H2SO4. So the ammonia that was liberated from 0.5 grams, this ammonia neutralizes 10 ml of 1 molar H2SO4. Then find the percent of nitrogen. Okay, see what is the weight of organic compound? So that is what, 0.5 grams. And normality of acid, Na, normality of acid and volume of acid we need. Normality of acid is 1 molar they given. Capital M stands for what? Molarity. How to convert the molarity to normality? Remember that normality is equal to molarity into N factor or valency factor. Here what is the N factor for H2SO4? It's a dibasic acid. So its N value is 2. So Na is equal to 1. 1 molar into N factor is 2. That is 2. Na value 2. And Va, volume of acid is how much? 10 ml. Now substitute the values in the formula. That is percent of nitrogen is equal to, I told you the formula, Na into Va into 1.4 by weight of organic compound. That is equal to, what is the Na value? 2. And Va value 10 into 1.4 by weight of organic compound 0.5. So 0.5. Then it will be 14 fours are. So nearly 56% will come. Okay. So once again, he given the weight of organic compound. When 0.5 grams of organic compound when he have taken, the ammonia liberated, and that liberated ammonia neutralized by 10 ml of 1 molar H2SO4. So the normality of H2SO4 is equal to molarity into N factor. So molarity is 1 and its N factor was 2. That is equal to 2. He has not given normality directly. They given molarity. So 1 molarity of H2SO4 is equal to 2 normalities of H2SO4. That is why normality 2, volume 10. So if you substitute, we will get the percent of nitrogen. Same, next model of this 0.5 grams of organic compound. So the weight of organic compound is 0.5 grams. Was treated by Jaldal's method. They clearly will mention which method, Diomasa, Jaldal's, they definitely will mention in the problem. The ammonia evolved was absorbed in 50 ml of 0.5 molar H2SO4. So whatever the ammonia that was liberated, first they send via 50 ml of 0.5 molar H2SO4. This is the excess amount. Then the residual acid, so the remaining acid, unreacted acid, the residual acid requires 60 ml of M/2 NaOH. The remaining unreacted acid requires 60 ml of M/2 means 1/2 molar. 1/2 molar means 0.5 molar NaOH. Then find the percentage of nitrogen. I gave you the one formula. Percent of nitrogen is equal to NaVa minus NbVb into 1.4 by weight of organic compound. The last fourth formula, NaVa minus NbVb into 1.4 by weight of the organic compound. Now tell me, Na acid H2SO4 is Na means normality of acid, but they given molarity. I told you how to convert the molarity to normality. Normality is equal to molarity into N factor. Its N factor was 2. 2 into 0.5, 1. Normality of acid is 1 into volume of the acid 50 minus Nb, normality of base, but here molarity of base they given. How much? 1/2 molarity. 1/2 means 0.5. But NaOH is a monoacidic base only. So its N factor value 1 only. So 0.5 into 1, 0.5 itself. So 0.5 into volume is 60. into 1.4 divided by weight of the organic compound 0.5. So calculate 50 into 1, 50 minus 60 into 0.5, 30 into 1.4 by 0.5. 50 minus 30, 20. So 20 into 1.4 by 0.5. So 20 into 1.4 means 28. 28 by 0.5. Finally 56% also. Again we got in the given problem. So likewise we can easily calculate the percentage of nitrogen. These are the two important models generally asking from Jaldar's method. I hope you understood this concept well. If there was any doubts, just ask me in the WhatsApp, or else you can directly call to my number also. I'll definitely will help you out. Until then, take care. Bye.